Hi friends, welcome to the NPTEL course on entrepreneurship. Today we have week 10 special lecture, continuing our focus on startup development methodology. And today's example is home gas detector. This is an IITM DOMS MBA entrepreneurship course project. The student credits are due to Advitiya Gupta, Jaykumar R, Manjula S, Nikhil Raj and Priyanka Tambe. Gases can be benign, but many gases can be dangerous. There are several flammable gases which are prone to cause fire when the gas reaches certain limits. Examples: hydrogen, hydrogen sulfide, methane, carbon monoxide, propane, gasoline, ammonia, acetylene, ethylene, and so on. The gases also become toxic and harmful when exposed for a certain amount of time. Again, examples are carbon monoxide, hydrogen sulfide, methane, and CFCs. Gases can also be suffocative. Deficiency and or quality of certain gases like oxygen content in air could be very detrimental to the health. And some of the harmful gases can suck oxygen out of the environmental system and cause a lot of issues. Chlorine, nitrogen dioxide, carbon dioxide are indeed highly suffocative gases. Why are we discussing this issue? Because without usage of gases, homes, offices, factories cannot function in the contemporary world. But the methodologies and the equipment to discuss gases, to identify appropriate technological solutions may be there in the factories, in big establishments. But homes are typically vulnerable to the dangerous gases and their spread. So I have offered this as a potential project, and the team has been very happy and committed to take up this project as a startup case study. So the team made its research and identified the problem initially and a solution as follows. Flammable gas fires and poisonous gas leaks are an important cause of major industrial accidents. Residences are also equally at risk because of such gas leakages and fires. Common causes are air conditioner gas and LPG leakages. Electric vehicle charging has now got added to the list. Industrial scale gas detection devices are available. However, simple, effective and affordable home gas detectors are not available. The team concluded, as I also observed, that home gas detector therefore represents a significant startup opportunity in India. There was further research and identification of flammable and poisonous gas leaks which could lead to loss of property, life, and which could cause huge monetary damages. The gas leaks at closed places are often not attended to in time, and if they are happening in the night time, nobody has any clue until it becomes very hazardous and fatal situation. Lack of proper gas detecting system which is smart enough to detect the leakage of gases and alert the users has caused majority of the problems in this arena. The following are some of the gases which cause accidents frequently. If their threshold is breached, they might cause serious health hazard to the people. Oxygen. Decrease of oxygen levels can be related with other gas leakages, and it could lead to an unconscious state and even to death. Hydrogen sulfide, which gets emanated from sewer, drainage pipes, inverter batteries, industry operations and so on, could be toxic and cause organ damage. Ammonia, which is typically released from chemical plants, could lead to eye, nose and throat irritation besides being toxic at higher levels. Methane, which is arising from compressed natural gas leakages and in industrial operations, is highly flammable. Carbon dioxide, indoor fireplace, poor ventilation, smoke, industry cause carbon dioxide levels to go up, and that could cause suffocation and death. Many solvents which are used in manufacturing plants or in cleaning situations could cause dangerous gas leaks and toxicity. Hydrogen could be from fuel cells, X-ray equipment and other industrial applications. It is explosive and flammable. Acetylene could be from welding, cutting, flammable torch and other industrial applications. It could cause suffocation, death because it is flammable. Nitrogen dioxide, it could arise from fuel, welding and commercial manufacturing, could be poisonous, cause heart failure and death, and so on. While some of these things are pure industrial applications, it is also possible that when those kinds of activities are undertaken in real estate operations or in house repairs, they could cause distress to the people who are living in the communities. There are players, of course, in the gas detection market. Honeywell, Emerson, Traeger, Siemens, ABB are some notable top-level players in the gas detector segment. But clearly, they cater mostly to the industry segment and not to households. There are some products that are available in the market. Portable gas detectors are available. Single gas brand of Honeywell, multiple gas brand of Tritex. Fixed gas detectors which are permanently installed at a location that has the potential to become hazardous due to gas leakages, infrared, ELDS, and so on. The top rated gas detectors for industrial use are Honeywell, Emerson, Siemens, ABB, and Traeger. And the features of these products are also provided here. They are good, they are from reputed companies, they are explosion proof, they are resistant to heat, offer high durability, and also provide rapid oxygen reading for combustion control optimization and emissions monitoring. There is no doubt that these are technologically advanced and provide some succor to the industrial operations which are exposed to gas leakages. And in terms of the household use as well, there are some products, particularly in India. Vignahartha True Safe Plastic Gas Leak Detector is there. Sticky Good Home Gas Alarm is there. But the reviews do indicate, as per the research of my team, that they are of cheap build and it is not really good to go in actual circumstances under repetitive conditions. Another set of products, i5 Tech Smart Home Security Wi-Fi Gas Detector Alarm, Netram Engineering High Sensitive Plastic Kitchen Gas Leak Detector, Triumph Kitchen LPG, PNG, 2-in-1 gas leak and heat detector system for home safety. Again, the reviews are poor and further examination by the team indicated that the reviews are justified. So there is a perception analysis about the products which are available in the Indian market. There are many negative views about these products. They are less modern, there is no battery backup, they are not aesthetically pleasing, difficult to handle, they lack connectivity features and do not provide alerts for physically challenged and so on. So this only has further fortified that gas detector, particularly for residential purposes, is a viable startup opportunity. So the problem is serious health issues and fatalities that get generated due to harmful gases. The need for safety alert for harmful gases in closed spaces with immediate timeliness. The solution, a smart gas detector which detects the presence of LPG, PNG, refrigerants, gases, flammable gases and raises immediate alerts to users through smart devices. The gas detectors market is not confined to India. Obviously, it is there all over, and a lot of importance is given to gas detector market in several countries. It is valued at $2.7 billion and it could reach USD 3.3 billion by 2026. As with any product, if you are able to bring a product which meets the requirements, that product could be very viable and could completely reshape the demand structure. So we have to view this particular project in the light of a disruptive product that could be put in market for explosive growth in the marketplace. Indian market dynamics are also good. From $1.1 billion, it could grow to $1.5 billion if the current rate of growth is maintained. However, there are several key impact areas which could lead to shift in the market dynamics. There are high demand situations for gas sensors in critical industries. There is intense pricing pressure because of the plethora of so many non-standard products that are available. There is an opportunity in terms of adopting gas sensors in consumer electronics, that is integrating and embedding in consumer electronics. And there is also the challenge of variability in demand due to inbuilt fail-safe methods of manufacturers of equipment. Given all of that, how do you ensure that the product really captures the market drivers or responds to the market drivers? Increased demand for gas sensors in automobiles for compliance with government regulations is one driver. Rising demand for safety systems in the oil and gas industry is another driver. Gas detector manufacturers collaborating with insurance companies to offer discounted home insurance policies is the third driver. Rise in the availability of high sensitivity gas detectors is the fourth driver. And finally, innovation in technology leading to product premium could be another driver. But all of these things are for structured, formal, factory and other operations. So how do you get to a good residential gas detector system? For that, as with the UV box, you have to analyze the technologies that are available. So the types of technologies that are available for gas detection are as follows. One, catalytic bead, where the bridge circuit uses two wire coil elements to transform the raw temperature change to signal the presence of combustible gas, and it is good for application in extreme climatic condition and vibrating machinery. Point infrared, whereby the concentration of hydrocarbon gas is measured via the infrared absorption. Detecting hydrocarbon gas, especially in low oxygen environments such as ducts, pipelines, mines, etc., is extremely important. Electrochemical uses electrochemical reaction that generates a current that is proportional to the gas concentration. Detecting toxic gas in the parts per million range or for oxygen enrichment deficiency in confined space is the right application for this. Ultrasonic gas detectors respond to the ultrasonic noise created by a pressurized gas leak, and this is useful for outer perimeter monitoring along property fence lines. Then there is the emerging gold standard, which is laser-based gas detection. ELDS sensors, laser optical technology, recognizes and analyzes a gas's specific harmonic fingerprint for outdoor and indoor places with high ventilation rates. The purpose of showing this table to you is to focus once again on the fact that deep research into science and technology is essential to develop a creative product solution and therefore an innovative business strategy for startups. This team has made a good study of the patented technologies. As you would have seen from the main course, study of the intellectual property that is available in the domain and also the patent estate of different competitors is necessary for understanding the kind of niche that is available for the new startup. So 2-3 patented technologies have been studied. Gas detection system and method using smartphone, a 2012 patent. A sensor-based wristband to detect and monitor arsenic gas in a mine, again 2020 patent, that too from India. IoT-based smart kitchen application for gas leakage monitoring, inventor country is India, year of patent is 2020. So which means that there is technological activity in this area. Therefore, the startup has to be not only technologically innovative and focused, but it should also be agile and adaptive to be able to come up with its product. Structural analysis, major players are there in the gas detector market: Honeywell, ABB, Dragawork, Siemens and Emerson Electric. While these players are there, it is doubtful whether they would develop the kind of products which are required for residential uses. Therefore, there is a clear opportunity in the industry structure to make a mark. This is again the turnover and profit of the competitors. Figures are less important than to say that even within the 5 people or 5 entity industry, there are companies which are leaders and there are companies which are close followers. So let's look at the final problem identification and solution definition. Gas detectors are of all types. In that we can have industrial use gas detectors and household use gas detectors. Industrial use gas detectors market is marked by big players, high entry barriers, especially based on technology and manufacturing capability. The market is already captured by prominent players. There is a wide variety of products and they generally incorporate the best-in-class technology. But as far as the household use gas detectors are concerned, there are very few prominent players. This market is easily penetrable and also it can be easily developed. There are, however, less barriers to entry. There is a large market size and current available products are not up to the mark. So this is the opportunity for household gas detection. So how is the final problem identification shaping up for the team? The team said that there are frequent leaks in LPG and PNG gases, refrigerant gases and flammable gases which cause a lot of livelihood loss and property loss. That is borne out by the news items we see every day referring to these kinds of leakages and fatalities. The gas detecting systems which are used to identify the leaks can be classified in terms of the technology, scale and the price in terms of industrial use and household use. Because the industrial gas detecting sector is dominated by many companies with strong presence, we need to look at the household segment where the currently available products are not up to the mark and do not meet the demand of wider users. They lack features such as alerts for the physically challenged. They do not have any measure of the estimated time left for evacuation. There is no device connectivity. The display about the strength of the leaked gas is not available. Extended battery backup with power support is not available. Service is not of high quality and so on. Therefore, there is a need for a product with the above mentioned features. So having identified this, the team went about working on this through the design thinking approach. So what are the customer requirements? Several features have been brought up as the customer requirements. Alerts which are visual and sound based, coverage of all the dangerous gases, SOS alerts on phone, and also SOS alerts to the nearest fire and police stations, because in such matters of fire accidents, it is the fire accident agencies that can handle the problem, not the household people. So fire and police stations must be alerted immediately. Handling connectivity issues, real-time monitoring of gas levels, lasting long even if not in use, battery backup, display of time, ability to cater to a wide range of users including those with disabilities, ability to raise alarm instantly, ability to measure the rate of spreading of gas, estimated time to evacuate to be communicated, and also child proofing, so that a child should not by mistake keep the product tampered. So this is the design thinking output. So when you are trying to develop this kind of product, there are always what if situations that you need to take into account. A couple of them are illustrated here. The team has done much more, but in the interest of time I'm not pointing out those things. So on site we need to have inbuilt speakers, flashlights, display units separately. But what if the user is away? Then you have to alert on connected devices and provide display of gas levels. And we also need to have immediate response to the hazard. We should send an SOS alert to the nearest fire station and to the nearest police station. Suppose you have speakers only in the device, people in different rooms can miss the alert. So the basic gas detection is no longer feasible. We need to use higher connectivity technologies, higher messaging capabilities and higher detection capabilities to be able to develop this product in the proper manner. Then you also have connectivity challenges. You want to do all that, but what if there is no Wi-Fi internet connectivity? Can eSIM or embedded SIM card generate SMS alerts? What if there is no network? How do you get the SOS? Can we have manual button pressing on the phone? Will it send an SOS to the fire station and police station? And rejected options. App only for Android. It's cost efficient, but iOS users may miss the alerts. So it should be operating system agnostic. It should be applicable for Windows, Android as well as iOS. What happens if it has to be done through only Wi-Fi? Not everybody can afford. So we should have LTE, 4G or 3G capable of taking the connectivity challenges. In case of a hazard, the electricity itself might go off, which can cause the Wi-Fi to be disabled. So we should have redundancy and fail-safe for such situations. What are the other connectivity issues? You have a regular power source, no issue. But what if there is no electricity at the time of gas leak, or the relevant phase power is not available? Limited time battery backup could be there, and particularly if they are nickel based batteries. But is there a chance when a gas leak occurs and heat gets generated that the battery itself will explode? What if the gas leak is a result of some other hazard? Can we have waterproof material, metal casing? Can we have childproof casing? Again, should we use lithium ion batteries, which are very popular in various other smart devices? We can, but then they can explode in high temperatures. Stainless steel for casing, durable but unnecessary costs. Wrought iron, soft and less durable. So how do you develop the optimal product? Looking at various kinds of issues such as these things. Again, as I said, these are sample issues. The reality could be even more challenging. And then you need a display. And display is the core. So the display itself has to be geared not for regular functioning but for SOS functioning. Date, time, temperature, battery levels, time to change, time left for evacuation, rate of gas spreading, gases covered and their levels must be displayed and then communicated. To accommodate maximum customer requirements in terms of delay, either you must have a large LCD screen or you may have two LCD screens to cluster the requirements and show them separately but together. So looking at all of these things, the team has designed a smart gas detecting system for households, which is illustrated here in a kind of rough sketch manner. This is equipped with an LCD screen to display current levels of gases, measures and estimates evacuation time in case of an emergency and displays it on the screen, sends initial alerts to connected smart devices when there are leaks in LPG, PNG, refrigerant gases and natural gases which are combustible in nature, sends SOS to fire and police departments if the gas level crosses extreme levels, is made with an explosion-proof and waterproof material technology, has an option to connect to power with extended battery backup. A multi-layer redundancy and safety system is imputed into this design, has options to connect through Wi-Fi and eSIM, has inbuilt speakers and flashlights. Upon initiation by the user, the device validates itself and displays the health of the device on the screen. It's kind of self-diagnosis to ensure that the design is actually in the right condition and the device is in the proper operating condition. So when you look at the device made by the team and one of the popular devices, the MRP is matched, but on various other parameters, this device of the IITM group scores current levels of gases at all times. The current device does it, the competitor doesn't. Evacuation time display, smart device alert, audio alert, visual alert, battery backup, eSIM, refrigeration, gas detection, clock and temperature display are all provided in this device, whereas only a couple of them, that is audio alert and visual alert, are provided in the competitor device. So clearly, with price being at par and with features being extremely robust, the device has got all the advantage. So the development of the minimum viable product and the ultimate desirable product, as I said in the main course, are iterative activities. So there is an initial design of the device which looks like a MVP. Then you do an iteration 1 when you bring in additional features such as SIM slot, user-friendly design, waterproof material. Then you do another iteration to bring in additional features such as added flashlights, additional battery backup. And you get to the final design of the device with display showing rate of spreading of the gas, time left for evacuation in case of a gas leak, sending SOS to fire and safety department. As you may appreciate, there may be machine learning, artificial intelligence involved in carrying out this kind of data analytics and have predictive capability to be able to alert everybody. So how do you do the product development plan? First, you gather information on customer needs and insights. It is a bilateral communication. You develop the final design plan and implement that plan with all the gathered insights. You model the product architecture, process flow, circuit diagram, etc. You assemble the product, you manufacture the components. Before that, select your vendors, develop an assembly line and test it for functionality, usability and stress. And then you deploy in the marketplace. The list of components that are required for a sophisticated product such as this are as follows: a microcontroller, a sensor, SIM SMS gateway, piezo buzzer, blink lights, LCD panel and battery. So all of these things are explained further, and that explanation probably is not relevant to my lecture, but what is relevant is that any startup project has to go deep into the science and technology so that you can identify the right components and the right product configuration. So the process flow chart of microcontroller function will be: start, read the gas level from the sensor, examine whether it is above the threshold level or below the threshold level. If it is above the threshold level, you have to send the alert to the phone, turn on the alarm, turn on the blink lights. And when that happens, you go to the delay which is permissible, and delay which is more than 0.1 seconds is not permissible in terms of raising of the alarm and turning on the blink lights. And for sending alert to the phone, a delay of not more than 2 minutes is permissible according to this flow chart. But if you are developing one which is superior to this device, you may say that a delay not more than 0.05 seconds and other communication delay of not more than 0.5 minute. You can think of such a thing so that you have competitive superiority over the startup product. Then you have a situation where gas level is below threshold level. Then you keep monitoring the displays of gas levels on LCD screen, and then you go back with a feedback loop to see how this gas level is moving up and down in the environment. So the block diagram of the microcontroller again is a combination of very sophisticated electronics, sensor, blink lights, SMS voice call mechanism, speaker buzzer mechanism, battery and display. And you need to have a high level circuit diagram to see how this microcontroller works and where it could work well and where it could go wrong. And each of these components which are indicated here are electronics driven, telecommunication driven components, and they need to be of high quality with ability to work under high stress conditions. Once you have these kinds of equipment, components, etc. done, we need to draw up a budget. The budget is that of the product, the amount in rupees, the quantity required and the total amount in rupees. And you can have a budget which covers all the components. The budget for extendable sensors are given here and summarized below. Once you have these kinds of budgets, you have to focus on the right vendors, because you develop a budget based on some initial discussions with various vendors. But once you have the overall budget, your objective must be to optimize the budget. And to be able to do that, you look at domestic vendors vis-a-vis foreign vendors. And depending upon the sophistication, you may choose an appropriate vendor. You may take quotations 1, 2, 3, L1, L2, L3 as they say, and zero in on the right vendors for this. The prototype manufacturing strategy is one that this startup can easily and effectively follow for rapid prototype building. You may do a native prototype building which would take a lot of time, but you can also look at retrofitted prototype building so that a hybrid of new and existing components can be created to lead to a new product. focusing on effective assembly strategy for the parts that are procured from different vendors and making sure that the fits and tolerances as well as electronic compatibility is assured. You got to do the body panel in a customized manner. They have chosen some vendors in Maharashtra, and similarly some materials have been used. Again, it is not germane to our discussion, but it only tells us what kind of steps, what kind of stages we need to go through for finalizing a prototype manufacturing strategy. How the materials, the way we make the materials is important for prototype development. Without prototype development, there is no startup that can be launched. So a lot of importance in proper design specification and equally proper prototype manufacturing. So from body panel customization, you place the microcontroller inside the body, connect the visible components, connect the sensors and the SMS gateway to the microcontroller, connect the battery and power source with the microcontroller. Every component is secured in place with visible units placed and sealed inside the cutouts made for them, and the body panel is locked. Again, it's a process of thinking that you must understand. If you don't go through these projects, if you don't simulate how a product is developed and finally manufactured, you will not be able to think how a startup can really get off the ground. What you learn will be theory, but this is practice and practicality, which you must absorb from these simulated exercises and case studies that I am providing to you. So once you do that, how do you ensure that there is a proof of concept? Is there need for the product? We have to demonstrate that the gas leak in closed places can lead to loss of human lives, property and health. So there is a lot of awareness situation that it exists, and the need for the product may be innately felt, may be felt when some accident takes place or when the authorities are alert, but it should be seen as a continuous need for the product. So you've got to ideate the right solution which meets the need, which we have done, then start demonstrating the proof of concept. So you have a laboratory, field laboratory, wherein you have got the existing products and the new product which you have developed, and then see which device meets all the functional, technical and management expectations in a better manner. Once you get this proof, you create a prototype and test it in a more robust manner. Document the feedback from the pilot users and create a minimum viable product. In this process, nothing gets done right in the very first attempt. It's a kind of iterative attempt, with each attempt leading to a better prototype and better journey towards the final functional product solution. So the proof of concept demonstration must be with reference to the foundation of this project, that is the gases that have a high probability of causing a disaster at home, and they have to be selected for the experiment. Levels of these gases must be measured in controlled conditions in an experimental setup using the device, and the values have to be noted down. The levels of these gases are changed higher or lower in the experimental setup, and then the device is tested to check if it raises an alarm in case the gas level crosses the threshold. And you got to conduct several experiments to check if the device correctly displays the gas level. And depending upon this sample, you have to design your experiments, use some statistical tools to ensure that there are no false positives or false negatives. So the type of the gas, hydrogen sulfide, the source could be any of the piping system. A methane gas, it could be arising from compressed natural gas. Oxygen could be because of the drawdown of oxygen due to other harmful gas leakages. Carbon dioxide could go up in indoor fireplace, poor ventilation, smoke. In winter times, it is not unusual for houses to have wooden inputs into generation of fire and heat that could cause toxicity. Even certain functions and certain religious events or community events involve burning of wood and other products which are flammable, and that itself could lead to carbon dioxide. So the environmental monitoring also may be done in gated communities, in and near the residences and so on, and this list can go on. So you got to look at these kinds of gases that are detected, see whether the product is detecting those gases and whether they are within the normal range, and whether alert is issued when the threshold levels are crossed. How do you test the product? The testing strategy is to be multi-layered. One is, of course, the design testing, circuit engineering, checking the performance and integrity of the electronic circuits. Functional working, checking the working of the microcontroller and other components. Stress testing, to test the durability of the device under severe alternative circumstances, and at times a combined experiment of all the gases getting released may also be done to stress test the product. Then how good is the assembly? Is there integrity of the components? Is there integrity of the assembly? And then usability testing. Are users in a position to use the product as per the specifications, as per the standard operating procedures, and the device is appropriately robust and appropriately communicative to the users to be able to fulfill its ordained mission. Now, once the product strategy is thus taken care of, we need to move into business strategy. Although this could be a work in progress simultaneously with the product strategy. What is my adopted strategy? Differentiation, focus differentiation. Differentiation in terms of focusing on the household segment. First, you look at the limited gas locations and then extend to the universe of entire domestic and commercial LPG connections. Then you further differentiate by proving that each of these features is capable of being measured, capable of being put on alert, and you can do this exercise so that you enjoy a premium for the product that you have built with lot of technology, lot of science, and also manufacturing rigor. So this strategy improvises on the existing products but takes a leap based on the new technologies that are incorporated, making this product entirely novel and creative to solve the existing challenges. As with other startup projects, you have this business model canvas which talks about the key partners, key activities, key resources, the value proposition, customer relationships, channels, customer segments, cost structures, revenue streams. This particular canvas makes you think about all the inputs to the business strategy and the operational strategy. The value chain of the company is starting from the primary activities and leading to the actual sales, service, and therefore the profit margin. Primary activities: sourcing, supplies and logistics, operations, distribution and outbound logistics, marketing and sales, service, profit margin. And there are many supporting and enabling activities like product R&D and technology, human resources management, general administration, and so on. In companies, product strategy is very much a determinant of corporate success. You look at the automobile industry, you look at the renewable energy industry, you look at the railway industry, you look at the smart devices industry, you will find that product strategy is at the core of the business strategy, and a well done product strategy, well executed product strategy determines corporate success. So we need to get your product strategy right, and that product strategy is always at the intersection of product design and business strategy. And the product strategy features the appropriate positioning of the product, and therefore the features that need to be there in the product, the kind of pricing which needs to be provided. We discussed about price elasticity of demand. We discussed about the entry deterrent price in respect of another project. Those things have to be relevant even here. Unit costs, they have to be kept down without compromising the quality, and you have to develop the approach of having disruptive features and patent the technology. Customer segmentation, because you cannot cater to all the segments as a startup from the very beginning. You got to choose your segments appropriately and move forward. Identify the core customer needs, and that could be interconnected safety device, highly communicative safety device, highly alert safety device, whatever it be. You focus on that core customer need and spread awareness on that. See to it that cheap variants cannot upset your plans. You got to face them and prove that they are not good enough, and get the highest market share based on the expected results. So you make a customer segmentation based on the city-wise data of the LPG connections, the taxpayers, people who use LPG cylinders, and then you arrive at an estimated market size and have a modest market share target in the beginning, which could lead to certain thousand units, have a growth plan and keep on increasing the volume level. The cost of goods must be maintained, if not reduced, and pricing premium should be maintained so that profitability is ensured. We must also recognize that there would be pre-operative expenses, particularly because this is a product and manufacturing oriented project. So you have to set up a manufacturing facility, you have to conduct market research, obtain necessary licenses, develop the functional and administrative act of doing this. You should also have time that is available to go to various investors, and that takes managerial bandwidth, founders bandwidth. You have to go for appropriate software for computerizing your operations, while ERP CRM software could be for larger volumes, but you need something basic to start with. And how do you promote the product, how do you prototype the product, how do you alpha and beta test the product, and what would be the total expense thereof. All of these things come under pre-operative expenses until the regular manufacturing and working capital cycle and the inventory management cycle are developed. The operating costs, direct materials, direct labor, prime cost, factory overhead at a particular percentage until you get the real idea of the factory overhead based on the costs you are aware of. The people who are employed, their salary levels, their direct and indirect overheads and so on. Therefore, you get the factory cost, you get the administrative costs, cost of goods sold, selling and distribution overheads, and total operating cost. Operation strategy, sourcing of raw materials, demand for components to be profiled for each quarter, raw materials to be ordered based on a particular credit scheme, and receivables have to be obtained based on a particular credit scheme. And you have to use 3 vendor quotations to ensure that you get the right kind of components at the right price. But where it is important, you may go for single sourcing or dual sourcing. Generally, at least dual sourcing is important on critical items. You have to design and develop an assembly line which can assemble the product, and you have to decide where you would have a centralized manufacturing facility and the kind of distance from various user points, and where and how you would store the product, etc. And if you want to have it as a B2C product, how would you distribute? And if you want to have a B2B or B2C, how would you select your channel partners, both online and offline? It is not unusual to have your own website, your own payment gateway, and your own direct selling, D2C, or you can have e-commerce platforms such as Amazon and Flipkart selling your products. You can also look at IndiaMart and other bulk selling websites. This is again same as the UV box example. And if you want to do offline, you need to have channel partners or distributors and dealers with whom you can have alliances. And you should also be prepared for on-call orders. Suppose there is a kind of accident in one region, suddenly you will find a spike in the demand and there could be many on-call orders. You should be able to manage your supply chain so that this surge demand is met properly. And how would you handle your marketing? You need to have a multi-state and multi-city awareness campaign. You should establish your unique positioning to start with, increase awareness of the need for gas detection, and keep on acquiring customers, let's say in batches of 10,000, so that you keep accruing the customer base. Then you should have a strategy to achieve the goals, right from starting a product website to having media mix, having offline media marketing, online media marketing, having affiliate marketing, etc. And for every activity, you should have a KPI. This is where this project has slightly differentiated itself. Whereas others talked about strategies, this team has talked about KPIs for each of the strategic initiative and how do I measure that my strategies are being effective. And then switching costs, migration possibilities, and how each of these things would be measured again in terms of KPIs. So a total marketing strategy is developed, and the strategy is across physical, digital, and omni channels. You start with a product that is meeting the foundational requirement. all the features: modern smart gas detector with a sophisticated design, displays current level of gases, estimated time left for evacuation, eSIM, Wi-Fi connectivity up to 5 devices, battery backup, explosion-proof material, SOS alerts to fire and police departments, blink lights for hearing impaired customers. Then you have price level, which is fixed at a particular price, and depending on configurations, the standard price could be elevated to other more remunerative price levels. Directly sold on company websites, online, offline, e-commerce sites, and available with residential property developers in partnership, etc. And promotion, wide launch through PR and social media. This is also a socio-economic project. It displays social awareness, so you can use all channels of promotion to make this product close to the residences and close to the citizens. Then you need a human resource strategy, which is functionally organized: technology, marketing, operations, finance and accounts, and human resources. And obviously the founders would share the CEO, CXO roles as much as possible. This is a typical enterprise establishment strategy which they have taken from a research article, and every startup may have its own enterprise strategy, but it is important to note that this research article talked about governance, it talked about information, knowledge, database, it talked about strategic intent, value chain and process, and products and services are one part, but the performance in the market is another part. Similarly, the entire ecosystem of suppliers, partners, alliances, clients, customers, and external influencers are seen to be influencing the enterprise architecture. That's how actually we need to develop a startup enterprise. It may be small, but every startup has to create its own ecosystem comprising all the stakeholders and stakeholder process that are listed here. Then you need obviously a cost sheet, all the costs and all the revenues, what kind of margin you would like to have, 20%, 25% or 15%, and then you can work this out both from the cost plus model as well as revenue minus model, and whichever works the best for the startup, that could be adopted. And fundraising, founder shareholding in various stages. Again, as I said earlier, we should bootstrap these projects with our own savings, so that as much as possible of the shareholding is kept with the promoters and the employees through the ESOPs. And thereafter, as the value is built in the product, you keep releasing a particular share of the capital stock to the investors. And if the project and the product is succeeding well, you will be raising higher levels of money at higher levels of premium, diluting lower levels of equity, which is the win-win situation for everybody. And this is a continuous development process in the fundraising. Important for that, investors need to appreciate the sales plan that you have, the revenue plan you have, and the profitability. While startups are expected to have some losses in the beginning years, today the environment is changing to ensure that startups also follow a robust business model with focus on profitability and robustness of the business model than on buying market presence and market share through liberally available risk capital. So you need to have a P&L statement. You can also look at other factors which other companies in public listed domain do: dividend payouts, how much you should buy back, how much you should retain in the company, and so on. So P&L statement and a balance sheet are necessary so that you understand the overall health of the company as it proceeds over the 5 years. Some companies, as you have seen, or some projects as you have seen in the past, projected for quarterly basis, some projected for 10-year basis, and this startup has projected on a 5-year basis. And the profitability metrics: gross profit, EBITDA, net profit, as percentages, as ratios, return on capital employed, return on fixed assets, return on equity. These are important metrics. So the summary execution model has been like this: you ideate, define the problem, find out the solution, apply design thinking, and fine-tune the idea 1 month. You develop a prototype over the next 2 months, design plan, finalize components and vendors, develop the prototype. Then take another month for testing of the prototype, usability, functionality, stress testing. Then you document the user feedback. You spend another month gathering insights, again applying design thinking, make appropriate changes to prototype. At that point of time, your MVP or the minimum viable product is almost ready. That should be worked on to make a fully functional solution, roll out the product in the market, get user feedback. It may take 4 months, 6 months, depending upon the team. Then you start developing the business model and find out how it can be launched, what is the product market scope, how can the business plan be profitable. That could take 2 months, but it doesn't end there. You got to actually manufacture and assemble a large scale production setup. The timelines could vary substantially. So whatever you have done up till now is the bringing the product to the takeoff stage. But for the product to really take off, you need to manufacture and assemble, roll out in select states and districts identified with data analytics. You should market the product based on branding. You should expand your product market scope. You should scale up and you should diversify. It is very important to get to this first set of activities, which is 3 plus 1 plus 1, which is 5 months, 9 months, 11 months. So you take 1 year to get to a business model backed by a minimum viable product. This is the minimum time required as estimated by this team for this kind of project. And thereafter, depending upon the resources you have and depending upon the proactive plans you have, you may be able to introduce the product in 6 months time or 12 months time. But you need to have funding to support this 2 years of activity easily. Now, this team has come up with some key learnings, while all the others also have come up. I didn't want to repeat everything, but this is representative of what every team has said. They said entrepreneurship is not only about innovation, but it is also about providing existing services in a better manner. Do not make assumptions. Consider all aspects before arriving at a conclusion. Entrepreneurship is a continuous cycle where you plan, design, develop, test, get feedback, and improve upon the product or service continuously. Brainstorm and gather several solutions before finally narrowing down to the one best or optimal solution. It is vital to possess knowledge about technical skills such as graphical designing, wireframing, UX UI designing, etc. to develop a technologically superior product. In addition, you need to understand the material technologies, the mechanical technologies, the electronics technologies, and the telecommunication technologies to deliver a technology-laden product creatively and innovatively. Always analyze data from multiple sources, especially market leaders and competitors, before identifying market gaps. So this is a template which will be useful along with the various templates we have discussed in this course and in this series of special lectures. Thank you. I'll meet you again.